With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. The question says that alkali metals and coinage metals both have ns1 electron in the outermost orbital. First part is, out of these two groups, which group element have higher stability? And explain that. Now second part is, compare the polarizing power of their cation, right? So firstly, let me write down the alkali metals which are present in the periodic table. We have lithium, sodium, potassium, rubidium, cesium. These are your alkali metals, that is metals present in group number 1. Then we have coinage metals, and those coinage metals are your copper, silver, and gold, right? They belong to group number, right? So this is the atomic number of copper. Let me just, there is no need to actually write down the uh, atomic number. We can simply understand this by that the question asked to us is that if you see at the configuration, we know that the electronic configuration of lithium is what it is: 1s2, 2s1. For sodium we have neon, 3s1, right? And so on. For potassium we have 4s1, rubidium we have 5s1, cesium we have 6s1. Now if you look at the configuration of copper, it is 3d10, 4s1, right? So I have written down the outermost valence shell configuration. So it is basically your 3d10, 4s1, right? So if you can see here, that means that both these groups have a valence electron with the same configuration, that is your ns1, right? Now the question is related to the stability of these two groups. So when we are moving from left to right in a periodic table, right? When we are moving from left to right, we know that the size of the atom decreases, right? So when we are moving, so the size of the atom decreases, because if you see in copper, silver, and gold, they have electrons present in their d orbitals and f orbitals. So because of the poor shielding effect of d and f electrons, their size reduces when we are moving from left to right in a period. That means, whereas if you compare it with the size of lithium atom, these alkali metals have larger size, right? So they will ease, because of their large size, the outermost electrons are loosely held by the nucleus, whereas in case of coinage metals, the outermost electrons are tightly held by nucleus. So that means alkali metals will easily lose electron, and since they're easily losing electrons, so that means alkali metals here are more reactive. So let me write down that alkali metals are more reactive, whereas these coinage metals, because the electrons are tightly held, so they are more stable, right? So out of the following, we have been asked which one is more stable or which one has higher stability. So let me write down that coinage metals have higher stability. Now in part B, we have been asked, compare the polarizing power of their cation. Now we know that in a bond we have, when we have a cation, let's say this is our cation and this is our anion, right? So polarizing power is defined as the ability of a cation to distort the electron cloud of an anion, right? So the cation is attracting the anion towards itself. So when we have to compare the polarizing power of the alkali metals and the coinage metals, what we need to compare is that, according to Fajan's rule, right? Let me write down here. So according to Fajan's rule, it states that the smaller is the size of cation, right? The smaller is the size of cation, the greater is its polarizing power. That means I'll represent it with pp. So that means the smaller is the size of cation, so the greater will be its polarizing power. So now if we have to compare here, we already know that alkali metals have larger size than or greater size than coinage metals, right? So let me also mention that so that you remember it, that the radius of lithium and it is greater than the radius of copper metal, right? So if that is the case, and since it is true that the radius of alkali metals is greater than that of coinage metals, so the smaller is the size because coinage metals have smaller size, so they have greater polarizing power. So I will write here the answer is coinage metals, that is copper, silver and gold. So the answer is coinage metals. So this is your answer for the particular question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.